Okay, so welcome to Chapter 5. The first lesson in Chapter 5 is about how to take the derivative of the natural log function. And so I'm just going to jump straight into that. There's no reason not to. Um, at this point, you should have a number of different derivatives memorized, and today I'm effectively asking you to memorize one new one. And here it is. The new one is that the derivative of the natural log function ln x is 1 over x. Yay, we win. There's a sense in which this lesson could theoretically end right now, this first video. I suppose I could stop now, because yeah, you know the derivative of natural log x is 1 over x. The thing that makes all of these problems more interesting is that, of course, you can still apply the product rule, the quotient rule, the chain rule to all of these things. And so the remainder of this video is just going to be me going through 3 different examples of derivatives so that you can sort of see this in action. So my first one, so example 1, find the derivative of the natural log of x squared minus 4. So there we go. I want us to find this derivative. Well, we know from the beginning that the derivative, the natural log of x is 1 over x. So if they want me to find the derivative of the natural log of x squared minus 4, I hope you recognize this is a chain rule problem. This is effectively a natural log function with x squared minus 4 plugged into it. Right? So the derivative of this thing will be 1 over, sorry about the hiccups again, not 1 over x, but 1 over x squared minus 4. So I've got 1 over x squared minus 4. Now the chain rule times the derivative of what was inside. Right, now what was inside? Well, x squared minus 4 was inside, and so the derivative of that is 2x. Great, so we end up just writing 2x on the top, x squared minus 4 on the bottom, and this is the derivative of the function that I was originally working with. So that was an example of me using the derivative of natural log in conjunction with the chain rule. Right. Let's move on to another example of this. In example 2, right, I could say if f of x equals, now let's see here, I had the natural log of secant x. Right, I want us to find f prime of x. So if you just sort of look at that question, think about it for a minute, hopefully you'll recognize what rule or rules need to be used, and hopefully you'll recognize that again is a chain rule problem, right? Here I have the natural log function, but instead of being natural log x, is natural log of secant x. So this should be really similar to the last one. I'd actually recommend you work this one out on your own. If we know that f of x is the natural log of secant x, it means that the derivative of that will be 1 over secant x, not 1 over x, but 1 over secant x, times, chain rule, times the derivative of what was inside. So times the derivative of secant x, which is, of course, I say of course because all of you have these memorized, secant x times tangent x. And really, you do need to have those memorized. I'll be honest, tomorrow you're going to be getting a whole, either tomorrow or the day after that, you get a number more of these things. We really need to keep those things consistently memorized. So yeah, I have 1 over secant x times secant x tangent x. But the reality is, this secant x tangent x is going to go on top of here, which means that secant x is actually on the top and the bottom. Those are going to cancel. I'll end up finding out that f prime of x, the derivative of that thing is tangent x. And we're done. By the way, I have to mention here, this is a little bit of foreshadowing. If the derivative of the natural log of secant x is tangent x, doesn't that tell us something about an integral also? Doesn't it tell us that the integral of tangent x is the natural log of secant x? It does. You don't need to know that for tonight's homework, but heads up, very soon we're going to be learning what the integral of a lot of other things are because we have this new natural log tool. I just have one more example. Both of these have been chain rule examples, and I'm not going to do a quotient rule example because it's just not a big deal. There are some of those I think there's one or two of those in the homework tonight. But let's look at a third example that brings a little bit more to the table. Actually, no, there's another way for me to do this problem that lets me review one other thing at the same time. Find the general solution. Oh wait, no, that'll be an integral. Sorry about that. That's just not gonna be there. We're just gonna find the derivative. Find f prime of x if f of x is. Oh, and I'm not gonna have room for that there. I'm making a mess of this. Sorry. If f of x is x squared times the natural log of x cubed plus 1. And as I wrote that down, you even heard me say times, right? And as soon as you notice that a function is times, when you're taking a derivative, you know you're going to need to do a product rule for that, right? So remembering the product rule, that there's a function here times a function here. So to do the product rule, we do the derivative of the first times the second plus the first times the derivative of the second. They basically take turns being the derivative, right? So I'll write f prime of x is, so now the derivative of the first thing is 2x. The second thing I'm leaving alone, so natural log of x cubed plus 1. Plus, this time I leave the first function alone, x squared, and I do the derivative of the second one. Now the second one is natural log, so that's going to be 1 over x cubed plus 1 times the chain rule, the derivative of what was inside, the derivative of that x cubed plus 1 is 3x squared. And I know I haven't done any simplifying yet, but that's sort of the answer before things get simplified. There's not a whole lot I can do with that first term, just 2x natural log of x cubed plus 1. This other one, I could take the x squared and the 3x squared and put them both in the numerator, and I'm usually going to be a fan of that. So that gives me 3x to the 4th, over x cubed plus 1. And there's a sense in which this answer is good. This answer is complete. You guys know lots of times I like to factor, so technically you could factor out an x from this one and an x from this one, but I just don't feel like it gets us a whole lot, so I'm going to stop here. So that's the end of this first lesson. The whole idea just being that the derivative of the natural log of x is 1 over x, and I want you to remember that you can use the chain rule and the product rule and the quotient rule in all of these problems. So I will see you in the next video.